Hey everyone, welcome back to my daily coding series. Today is day 88. I'm going to continue working on these interval problems and just do the next one. Okay, so just a reminder, I've never seen this problem before, so let's try and see what it is. Okay, so it's called non-overlapping intervals. So we're given some intervals, which is basically, we're given an array of intervals where every interval is a array of size 2, which has a start and end component. Okay, and then our task is to return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Intervals are non-overlapping even if they have a common point. For example, 1, 3, the interval 1 to 3 and the interval 2 to 4 are overlapping. But the interval 1 to 2 and the interval 2 to 3 are non-overlapping. Okay, so I think I get the problem. So we're given some intervals, and then we have to say how many we have to remove to, so that we have non-overlapping intervals. So in this case, we're given these intervals, and if we remove 1, 4, then the remaining two intervals will be non-overlapping. Of course, we could also remove both of these, and then this would be non-overlapping, but we need to return the minimum number of intervals. So there are many combinations, but we have to return the minimum number of intervals. And this one is already non-overlapping. Okay. I wonder if there are many possible ways to do it. So yeah, there must be. So for instance, let's say we have 1, 5 and we have 4, 9. So in this case, we have two intervals that overlap with each other, so we can remove either one. But it doesn't require us to say which intervals we have to remove. Yeah, it doesn't require that. All right, this seems honestly like a really tricky problem, to be honest. I'm not sure exactly where to start. So let me just go through some examples. So if we have like 1 to 4, 2 to 10, I mean, a good idea to start might be like maybe we should prioritize the intervals that cover the most distance. But let's say in here we had, let's say like 3 to 4, 4 to 5, and 5 to 6. So these aren't overlapping. So if we go by the most distance, then we would say, okay, these are overlapping. Let's keep the one with the most. Oh, maybe we should get rid of the one with the most distance in this case. Yeah, because the distance doesn't, we just want to make it not overlapping. So maybe we should get rid of the one that has the most distance. Okay, so here we've detected an overlap. This one has a distance of 2. This one has a distance of 8. So we should remove this one. Okay, and in that case, this would work, but what if we have, let's say, 5? So this still has less distance, but what if, let's make this 4. Now what if we have 2, 3 in here? Whoops. What if we have, instead of it being there, I guess, I'm basically trying to make an example where when we're confronted with a conflict, that it makes sense to actually remove the smaller one. But I don't know if I can craft an example like that. So let's say this was, and I'm just assuming that it's sorted. Yeah, maybe that's how you do it, is you just always remove the bigger one. So my question is, when you detect a merge, can you always just remove the bigger interval? In other words, is it possible that removing the smaller interval is the correct choice? So this is the question that I'm trying to figure out. Is it possible that removing the smaller interval is actually the correct choice? So I guess the idea that I have right now is you kind of just linearly go through it, and then when you encounter a conflict, like an overlap, then you remove the larger interval. That is the interval that takes up more distance. And then you just get, and then hopefully that like works. But if I can find an example where removing the smaller interval is the correct choice, then that means that this does not work. We can't just indiscriminately remove the larger interval. So let's look at the examples here. So here, 1, 2, 2 to 4 is not a conflict. Well, let's say I had it sorted first, actually, because that's an easy way to find overlaps. Okay, so it'd be like this. So the first conflict we find is this one. So I would remove this one because it's larger. And then we have no more conflicts. And so it works with that one. And then this one, we have no overlaps. All right, so let me try to think of an example. So in this case, yeah, I guess it just... yeah, so what if this was like 2, 5? Well, why would we ever remove the smaller interval? What if this was... okay. What if this was 1 to 4, and this was 2 to 5? So in this case, they're both the same. Yeah, so what if intervals are the same size? I'm trying to think, is there a way I could make this one smaller? But yeah, there is. I just have to do this. Okay. Now let's just increase everything. Uh, 5. Okay, this might be an example. So here we have an interval of size 4. Here we have an interval of size 3. So according to our method, we would remove the smaller one. No, we'd remove the bigger one. So when we remove this would actually be an incorrect removal. Or would it? Well, because this is... removing this one, I think, is still fine. No, it's not. We want to remove this one. We want to remove the smaller... Okay, so here's an example. So in this case, removing the smaller interval, 4 to 7, is actually the incorrect move. Yeah, so why? That's because it merges... All right, maybe yeah. I was gonna suggest that we could count. So this would be slow, but we can count like, okay, how many of this do I overlap with? And then we'd say, okay, this one overlaps with 1. That's just this one. And now the second one overlaps with 2. And then the last one overlaps with 1, which is this one. So first of all, this seems hard to calculate. And also it doesn't necessarily, like, just because, I wonder if this, like, you can represent this like a graph or something. So you know that this one overlaps this one, and you can point to like which it overlaps or something. So let's say we could get this data. So let's assume that we can know how many intervals and which intervals every interval overlaps with. What can we do with that? Could we just remove the... Is it best to always just remove the interval that overlaps with the most other intervals? So in this case, we would delete this one, and then from every node, if it overlaps with it, we would change its count to 0. So that's been deleted, and then this would be 0. Yeah, and then once everything is 0, you stop, I guess. So okay, so we know that. I'll just keep those. So in the first example, it would be, so I'm going to look at this like sort of graphing thing, and maybe it'll lead me somewhere. So if we look here, this overlaps with 0. This one overlaps. Actually, I got thrown off. This overlaps with 1. Right, yeah, just 1, 4. This overlaps with 2, and this overlaps with 1. So it's kind of similar. I'm noticing that you want to prioritize removing the one that overlaps with the most other intervals. So now my question is, do you always remove the interval with the most overlaps? So in both of the examples so far, the answer is yes. Can I think of an example where that might not be true? I don't know. So let's say we have like a big interval. Yeah, so now the distance isn't really relevant. It's more of just how many problems does it cause. So let's say this is like 8 to 12, and then we have like 11 to 12. Okay, so here's an example. This one overlaps with 0. This one overlaps with, let's see, just 1 actually, just this one. This one overlaps with 2. So it overlaps with this interval, and it overlaps with this interval, and this one overlaps with 1. So in this case, yeah, I'm seeing a lot of this 1, 2, 1 structure. So what if we had something like this was 14? Okay, so in this case, 8 would overlap, or this interval would overlap with 1, 2, 3. Now this one would overlap with just 1 and just 1. So we can kind of see, like, when we put it in terms of this, it becomes pretty obvious that 3 is the answer in this case. What if we had something like at the end? So this is all kind of one part. But then if we look at, let's say this was like 16, 18, and 17, 19. So now these overlap with each other. and they're not related to this one. We could also have something that overlaps two things. Like, what if this was 13? Yeah. Okay, so in this case, so the sum of these, I think, always has to be even, because one overlap causes two intervals to have an overlap. In this case, does it still make sense to remove? I think it might not actually make a difference in this case. Like, you have to remove this one and then at least one of these. So I don't think the order would matter, but let's say if you did do this one, then it would become 0, 2, 1, 1. Okay. So can you have three intervals that all overlap with each other? I would say yes. So let's say something like this. So in this case, this overlaps 2. This overlaps 2 as well. And this overlaps 2. Yeah, so in this case, only... Okay, so I'm kind of thinking of it in terms of like clusters or something. So you kind of want to group it. So if we were to draw it out, we'd want to put the intervals into groups and figure out for each group, how do I get this group so that it's not overlapping in the shortest number of, like, because each group is kind of a separate problem. And what I mean by group is, like, if this starts with 16, for instance, and none of these numbers reach this point, then this is kind of like a new subproblem. Like, the answer to these intervals will be completely independent of this. So maybe we can, instead of focusing on solving the whole problem, we can just focus on solving one subproblem and then repeat that for the whole problem. So how do we solve one? So what is a sub? Okay, so so how do we define what a subproblem is? So in this case, how do we define what a subproblem is? I would say it's the point, like, if we were to merge, for instance, if we were to merge all of the intervals, if you could merge all of the intervals into one interval, then it's a subproblem. So we can't merge any of these with this one, but we could merge all of these together into 1 to 13. Yeah, I don't know. I'd be pretty shocked if, like... Yeah, I guess an algorithm for me isn't, like, emerging yet, but... All right. Yeah, I guess. So far I haven't been able to disprove that you just remove the interval with the most conflicts. I think it makes sense to do that. I think we can assume. I'll just say. So I'm going to, for now, just operate under the assumption that we remove the interval with the most overlaps. Because I can't imagine why you would not. Why would you not do that? I think you want to remove it with the most overlaps. So how do you get the number of overlaps? I could see an algorithm for that, but it wouldn't be fast at all. But maybe I could start with that. So it would be sort of like n squared. So you'd start with this one, and then you'd say, so you have like a graph or something, or just like a dictionary, and we say that, and our interval is unique. I guess. Yeah, I'm not. Okay, so this would work if the intervals are unique, but I don't think there's any guarantee that they are. Because here, if we had like two 814s, then that would complicate everything. I guess I can assume. Let's just say. Assume no duplicate intervals, just to simplify the problem so I can get somewhere. So I would start with, so I'd have the key of the dictionary be a tuple, and the value be a set. And in this would be everything that this overlaps with. So we'd say 1, 4 overlaps with 4, 10. And that's it. So now I'd move on to the next one, and I'd say, well, I guess also what you would do. Oh, maybe it's not. Maybe it's not n squared. Because when you add this one, you know that you can add it here. And then when you get to this point, you can assume that you only have to look to the right. Okay. So maybe it's linear. Okay, so now in 410, we can add to this set. So we'll add 8, 14. Like so. I'm going to get rid of these separating commas just for clarity. Let's assume no duplicate intervals for now. So we can add 814, which means that 814 will have 410. We cannot add 1113 to this one. Okay, so now when we go to 814, yeah, and we've basically done. There's a little bit of backtracking, I guess. Wait, maybe there's a lot of backtracking. Yeah, I'm just thinking like, okay, so we had to check 1113 to know that it doesn't overlap, but then we did go back to 814. So what if there was, for instance, a 912 of sort? And let's say this was 811. So in this case, we'd put 811, and then 811 would give us 410. And then when we get to 912, right, so when we get to 912, does that give us information about 812? Or, sorry, 811. So we get to 912. And so we know that that's going to overlap. So first of all, we'd put 912 here. And then that means we would put 912 here with 410. Now my question is, do we inherently know that this interval will overlap with this interval as well? I would say yes. I think that has to be true. So like if we have this, so if it's sorted, first of all, and we have that this interval overlaps with this interval, then that means that this interval also has to overlap with this interval. I think so, because if we have, and this is important, so if we have like 1, 9, well, no, it's sorted. So if we have 1, 4, 1, 9, and then like 2, 3. Yeah. What if, well, maybe not. Maybe not. So let's say this was 1, 10, and this was 2, 3, and this was, yeah, okay, so no. So, yeah, it's not true. So for, in this case, it's sorted. This interval interlaps with this interval, but that doesn't mean that this interval necessarily has to. So then this approach would be n squared. Okay, so maybe I can just do an n squared thing for now. So then I'd go until you can't, and then I'd go to 8, 11, and then I would go, and I'd get all of this. So let's assume that we have this. So what do we do with that? I mean, could you have, so maybe if we had another dictionary which was like the count of each, like the length. Or maybe we'd want it in like a heap. Yeah, so I mean, obviously this doesn't seem like the right way to do it, but I'm just kind of going with it. So we'd want to basically extract the maximum value, which is why I'm suggesting a heap. So we would have like, for this example, all right, so let me do this example. So this intercepts with 0, this intercepts with, with 2, this intercepts with 2, this intercepts with 2 as well, this intercepts with 2, and this intercepts with 1. This one only intercepts with this. This one intercepts with 3, actually, I think. Right? Because it intercepts with this one, actually, too. And this one. And this one. Okay, yeah, that makes sense. So now it's even. So what I would say is in our heap, we would have like 3 and then the interval. So the count that it intercepts with, and then, you know, something like this. But we'd have to, yeah, so the idea would be, okay, so you pop from the heap, you remove the one with the most connections, but then you'd have to update all of the connections and like re-get the counts. So this would be very slow. I think it would work though. But yeah, I'm going to take a break and then come back and look at the solution and go from there. Hey guys, I'm back. So I was looking at these hints here. Also, I should have looked at this. O log n, n log n. Okay, so these hints, the first one says what like when two intervals overlap. This one says the brute force would be to recursively do it, which I guess for interview thinking, like it's good to start with the brute force and go from there. I just didn't really know what the brute force would be for this, but I guess it makes sense. Okay, so now hint 3 and 4 are kind of saying the algorithm on how to do it. So, and it also suggests that you should sort it. So I'm just gonna get rid of all that for now. So it's saying we iterate from the second interval. So we have like previous end. So we iterate, so we'd have like a variable called like previous end, which is 2 in this case. So we start it at the first one, and then we iterate from left to right. And then if okay, so if they don't overlap, then we just make previous end 4. If they do overlap, we set previous end to be the minimum. Okay. So in this case, they do overlap, so we set previous end to be the minimum, which would just be 4, and then I guess we would just remove the 1. Okay, so we just, basically the greedy approach here is you choose, you can assume that it's better to remove the interval that goes further right, or has a higher max value. Which I guess does make sense, because that's the only thing that really matters. Okay, so let's code this up. So, and then we just return an integer. So we'll grab the first interval and its last value as previous end. And let me just look at, so the intervals can be length 1, which in that case, the answer is 0, which I think would be fine as well. And then we'll initialize results. Okay, and we'll say while I is less than length of intervals, we want I to go up by 1. Okay, so in here, what we'll do is, so we can check if they merge. So if intervals of I of 0 is less than previous end. So this would be a merge. So if where we are, so let's say, let's just alter this for a second. So let's say we have 3, 5, right? This is a merge. Let's look at the first one. So previous end is 2, I starts at 1. Okay, I starts at 1. So 2 is not less than 2, so we don't merge. So I just goes up by 1. And now, and we update previous end. So if we don't merge, I'll just say this for now. If we don't merge, then previous end basically just gets updated to intervals I of 1. So now previous end is 4. And then we go back. Okay, so now 3 is less than 4, so we merge them together. So what does merging them together really look like? Well, in this case, result would go up by 1. And also, so previous end would become the minimum of itself and intervals I of 0. So because we're removing the bigger one, so we keep the smaller one. Okay, let's see if that does it. Okay, so in this case, we have 3 intervals of the same length. So we set previous end to be 2, and we set I to be here. And then we detect this as what? Not merging. Although it should be, right? So here, intervals I of 0, 1 is less than 2. Result goes up by 1. And we set previous end. I think this should be 1. Because I was setting it to the left value instead of the right value. Alright, we have another error here. So I'm outputting 3, but we should output 2. Because if you remove this one and this one, I think. Oh, I'm not sorting. Alright. There we go. Alright, and then this if-else statement here. Yeah, I think it's justified. Yeah, I think it's justified. Okay. So, I think, okay, so obviously I looked at the solution and I got it. How could I have gotten this by myself? The trick to this problem was really the assumption that if you find a... Yeah, okay. So when I very first started this problem, my first assumption was you should get rid of the interval that has the most distance. Instead, so that doesn't work. Instead, I should have said, or should have thought, that the distance does, if we're going left to right, the distance doesn't matter. The only thing that matters is how far to the right does the interval go. And then you prioritize based on that. So that was basically the key idea, is you get rid of the interval that goes furthest to the right. And then, yeah, the implementation was pretty straightforward. But okay, thank you guys for watching. That was day 88. Yeah, thank you.